In this video, I will introduce alkenes and alkynes and their IUPAC naming. Alkenes are the hydrocarbons containing one or more double bonds. These double bonds are in between two carbon atoms. Whereas alkynes are the hydrocarbons containing one or more triple bonds. The triple bonds are again between carbon-carbon atoms. Both alkenes and alkynes are called unsaturated hydrocarbons because the carbons do not have the maximum number of hydrogen atoms attached. But still, as you can see in here, all the carbon atoms still makes 4 bonds. In alkenes, 2 of them will be double bonds, and in alkynes, 3 of them will be triple bonds. In this picture, you see the simplest alkane with 2 carbon atoms, and we call it as ethane. And in here, it's the simplest alkyne with 2 carbon atoms, and we name it as ethyne. Let's do a learning check. Identify each of the following compounds as an alkene or alkyne. You can do this by your own, just looking at the bond types in the compounds. You can determine whether it's an alkene or alkyne. Yes, A is an alkene because this contains a double bond. This is a double bond. And this bond is a triple bond. Therefore, B is an alkyne. Alkene and alkyne. Okay, the IUPAC namings for alkenes and alkynes is very similar to alkanes. The only difference is you just have to replace the ane in alkanes with ene or ines for alkenes and alkynes respectively. And cyclic alkanes are named as cycloalkenes. We'll do that in the future slides. Now let's see a comparison of the names for alkanes and alkynes in here. Now if we take the simplest alkane, which is ethane with 2 carbon atoms, and we go with the IUPAC naming conventions that we learned in our previous lessons. The respective alkene is named as ethane. You just replace ane with ene. The ethylene is the common name used for ethane. It is not an IUPAC naming, but IUPAC name is the ethane. The respective alkyne with 2 carbon atoms is ethyne, and the generic name is acetylene. Just like that, the naming becomes different as it becomes an alkene or alkyne. And the example for 3 carbon atoms containing hydrocarbons: propane, propene, and propyne. Okay. Now let's do this example. I want you to pause the video and try to write the IUPAC names of both of these structures A and B, and then come back and check your answer. Okay, now let's try to do structure A. I'm gonna show you how to determine the name, IUPAC name for the structure A. Now, when you have this type of question, first of all, you need to okay. First of all, you need to uh, check what is the longest carbon chain. Now, the longest carbon chain in structure A contains 1, 2, 3, 4, 5 carbon atoms. So I will start with the alkane name. This is an alkene, but I will start with alkane name because that's what we know. If there are 5 carbons in a carbon chain, if it's an alkane, we name as pentane. Now, in this example, we know that this contains a double bond. So I will name that as, I will change the name to pentene. I just replaced ane with ene because of the double bond uh, structure. Now, we see that there's a substituent attached here, and it's a methyl group. This is a methyl group. Now, the next step is to determine uh, the position of the double bond, or how to number, or from which side to start numbering. Now, when you are numbering this 5 carbon containing carbon chain, you need to number in such a way that you have to give uh, the lowest number possible for the double bond containing carbon atoms. So I can fulfill that by starting numbering from the left hand side. 1, 2, 3, 4, 5. In that way, the double bond containing carbon atom will be in it's carbon 2 and 3. But when we are doing the IUPAC naming, you always need to give the number of the carbon atom, which you need to give the lowest number for the carbon atom containing the double bond. You don't give 2 numbers, you give just 1 number. So you can say the position is 2. So it will be, I can write it's 2-pentene. Now, don't forget the methyl group. So we need to give the position of the methyl group as well. So now the methyl group is in the 4th carbon atom. So I can write this as 4 dash methyl dash 2-pentene. Okay, so that's the correct IUPAC name for the structure A. So when you have a double bond, you need to always give priority to give the smallest number possible for the double bond containing carbon atom. So we only give just 1 number for the double bond containing carbon, which is number 2 here. So that's why it's 2-pentene, not 3-pentene. Okay, now let's do the structure B. The answer for structure B, I will discuss that. Now this is a line angle structural formula. Now the first task is to find out what is the longest carbon chain. Now to visualize how many carbon atoms are here, let me write the carbon atoms in the corners and in the edge. So here there's a carbon atom, and there's a carbon atom here, and one here, and there's one here, and one here, and another one here. So this is something that students get confused with. Locate the carbon atoms, the invisible carbon atoms in line angle structures. So whenever there is a carbon-carbon double bond or carbon-carbon triple bond, you need to make sure that you place the carbon atoms in the correct place. So if you have a double bond or triple bond containing carbon, make sure you keep carbon atoms on both sides. And in this one, there is another carbon atom here. Um, if you had a structure like this, a line angle structure like this has how many carbon atoms? One here, and one here. Okay. And if you had a structure, like this, how many carbon atoms are there? One here, one here, one here, and one here. Okay. So those are some things that you need to take down. I just lost my drawings. That's okay. Let me okay, I guess you can go back and find the drawings that I made. So please note down the difference between the locations of the carbon atoms when you have a triple bond. Okay, I'm gonna label the carbon atoms again in here. Okay, now how many carbons are there altogether? You have 6 carbon atoms. So if there are 6 carbon atoms, the prefix is hex. Since this is an alkyne, it should be hexyne. Okay, it should be hexyne. Now, don't forget to put the number in front of the name. The number has to be the carbon atom containing the triple bond, and that has to be the lowest possible number. So I will get the lowest possible number if I start numbering from this end. 1, 2, 3, 4, 5, and 6. Okay, now in this case, you get the lowest number possible for the carbon atom containing the triple bond if you start numbering from the right hand side, which is number 2. So the name has to be 2-hexyne. The name will be, okay, the name will be 2-hexyne. Again, I'm gonna do the numbering. 1, 2, 3, 4, 5, 6. Okay, that's the IUPAC name for the structure B. Now let's see cycloalkanes. These are the compounds with a double bond within the ring structure. So you can identify cyclopentenes, cyclohexanes, like that. And then the naming of cycloalkenes is done by assigning the double bond to be between carbon 1 and carbon 2 if there is a substituent attached to the ring, just like in this example. Now, a methyl group is attached to the cyclopentene. Now, we need to number this cyclic structure, giving that the carbon 1 and 2 to the double bonds containing carbon atom. And also, you need to make sure you are giving the lowest number possible for the methyl group as well. So that's why we are numbering from to this side, but not this side. Because if you do it the other side, you get the number 4 for methyl group. So we choose this way because we get the smallest number possible for methyl group. Anyhow, you need to give the 1 and 2 positions to the double bonds containing carbon. So that's the rule. Now, once you figured out numbering in the correct way, the next step is to locate the methyl group is in the third carbon, and then you can name this compound as 3-methyl cyclopentene. And we don't write the position of the double bonds in the name because it's understood. And also you don't keep a space in between methyl and cyclo. Those are according to the IUPAC rules. Okay. Now, I have this example. First, I want you to try this by your own and then come back and check your answer. Okay. The first structure is a cyclohexane. The name of the structure is cyclohexane. I will just write as it is. And um, when there is one double bond in the cyclic structure, the double bond containing carbon atoms has to be always carbon 1 and 2. So we don't write the position of the double bond as one cyclohexene in this case because it's understood. The name is just cyclohexane. Cyclohexane. The second structure, it's a cyclopentene and it contains 2 methyl groups attached to the same carbon atom here. Now, according to the rules that I mentioned, you need to start numbering this cyclopentene, giving the number 1 and 2 to the double bond containing carbon. And in this way, like the methyl groups are in the third carbon atom. So the name should be, since there are 2 methyl groups, you need to mention that there are 2 methyl groups, right? So you just have to write 3, 3 dash. To show that there are 2 methyl groups, we say dimethyl. Dimethyl, and this is a cyclopentene. You write cyclopentene. So this is the correct IUPAC name for this structure. Since both of these methyl groups are in the same carbon atom, we say 3, 3. If the methyl groups are in 2 different carbons, for example, if it's in the 2 and 4 or 4 and 5, you say 4, 5 or 3, 4 like that. I mean, in any other example. So we put a comma to separate the positions and put a dash and then begin writing the number. We write di, tri accordingly to show that there are multiple substituents. So this is the correct IUPAC naming for this structure. If you got it, done. That's great. If not, that's fine. We are still learning. You'll practice more when you do more problems.